Okay, ladies and gentlemen, let's talk a little bit about probability. Now, probability has to do with a lot of different things in life, whether it be games, whether it be gambling, the chance of something's going to win, or as today, here, I'm doing this on a snow day. We have about 6-8 inches of snow on the ground. And so when you look at the weather, they say, hey, there's a 40% chance of snow or whatever it happens to be. So let's go to my app and let's take a look at the weather. Now, it says it's going to snow tonight and it's going to go up through tomorrow morning. You know, how do they do that? Well, they use actually mathematically modeling to figure out when it's going to snow, how much it's going to snow, and what the chances are. Now, it says 4 to 8 inches, but I want you to take a look at something here. It says snowfall probability. Now, you'll notice right here, if you will take a look, the biggest bar is here in that 4 to 8 inch area. And they say that that is 55% likely to happen, which means that they can't guarantee it's going to snow 4 to 8 inches, but if they use their math and they've done their math correctly, there's a 55% chance that by the end of tonight, when I wake up tomorrow, there's going to be somewhere between 4 to 8 inches of snow on the ground. So this actually, by the way, if you look at it this way, is a whole different level of probability, but we're not going to get into that. Let's take a look at probability more broadly. There's all types of probability, but the most simple probability is right there. Okay, we've all done this before. You want to know who's going to get the ball first at the ball game, so they take the coin and they flip the coin. And here's the deal. Underneath my hand is one of two options. It's either going to be heads or it's going to be tails. So if it's heads, one team gets the ball. If it's tails, the other team gets the ball. Now, I'm not even going to show you. Ha ha ha. But the idea here is there are two potential outcomes, heads and tails. Now, in this case, this is a District of Columbia quarter, so justice for all, apparently. Don't know. It looks like a piano. It looks like it's sitting in front of a piano. But so, two options. I could do it with any coin. There are only two options. Okay? And each one of these options, heads or tails, is called an outcome. An outcome is a result of an experiment. Now, in this case, I didn't do a big fancy experiment. The experiment was simply flipping a coin. But what we can say is a result of an experiment or a trial. Now, not like a trial with a jury, but trial in the sense that, here we go, we're going to flip it once, and I got tails. I'm going to flip it again. This would be a second trial. I got heads. So every time you repeat the experiment, you get a trial. So it's a repeat of the process. Now, in this particular case, the outcomes happen to be head or tails. But let's take a look at a different experiment. I have some candy here. I'm going to pour it in the bowl. In this particular case, I have, I don't know, maybe 20 of these little candies here. We'll get them out and count them a little bit later. But if I were to put them in something that I can't see, okay, you can see it, but I can't see it from here. So here, we'll just put it like this. And I pull one of these out. I pull out a, that's red. I don't know if it shows up to red to you or not, but it's red. Now I'm going to put it back, and I'm going to swirl them around, and I come out with purple this time. Each one of those is an outcome. And traditional or classical probability is defined by the number of outcomes over the total possible. So, for example, in our coin example, we either had heads or we had tails. And so the probability of heads was 1/2 because there's only one head out of two possible sides. Tails is also 1/2. Now, this also brings us to another really important point. because if I add those two up, 1/2 plus 1/2, well, half plus a half, that's a whole. The probability is 1, so total probability should always end up being 1. Now, in this particular case, let's take a look here. I'm going to take out my candy, and I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That'll be enough candy for right now. So, I have 15. So, if I roll these around and then I start picking randomly, even though I can't see, and I get, purple. Well, what's the chances of me getting that purple? Well, I need to know how many purples are in the bucket. So, there was 1, 2, 3. So, in the case of the candy, I have purple, I have 3. Now, I also have, let's see here, green and orange. So I have green, that's 1, 2, 3, 4, 5. And then I have orange, the 1, 2, 3, orange, get 3. I have red, red is 1, 2, and yellow is 2. Now, let's see if I counted correctly when I did it the first time. 5, 5, 5, yep, that's 15. So I have a chance of getting purple is 3 out of 15. The chance of getting green is 5 out of 15. Orange, 3 out of 15. 2 out of 15. 2 out of 15. And together, all of those are going to be 15 out of 15. Because in probability, everything always has to be from 0 probability to 1 probability. Now, you could also think about it like percents. You could say, hey, there's a 0% chance and there's a 100% chance. Now, why does that make sense? Well, we've talked about previously that you can't multiply by percents. You can't use percents in math equations. But what you can do is you can turn them into decimals, okay? And decimals, of course, you can also turn fractions into decimals. So 0.33 repeating is 5 out of 15. Or 0.2 would be 3 out of 15. So in each of these cases, the probability is always on a scale of 0 to 100% or 0 to 1, with 50% or 0.5, 1/2, 50% being in the middle. If something is right in the middle, it's equally likely. If it's all the way over here at 100, if there's a 100% chance of snow, then it's guaranteed, it is guaranteed. I'm not even spelled guaranteed. Or it is going to happen, okay? It is certain. Now, if on the other hand, there's no chance, like that I'm going to win the lottery. Well, I didn't buy a ticket, so I can't win the lottery. By the way, huge choice of probability. It would be not possible if I didn't even buy a ticket. It's not possible. There's 0 chance that I could win. So what we have is we have trials, okay? That trial resulted in an event. That event was an outcome, so a result of a trial. And we also have probability, and probability has to be between 0 and 1, or 0% and 100%. Classical probability says I have outcomes out of total possible, and so that is some very basic stuff. Now, before we go, I know we're getting a little long, but before we go, let's take a look at some dice. So if I have a standard old dice, it has 1 on this side, 2 on that side, 3 on this side. So there's a total. What's the probability, P, of getting a 1? Well, how many faces are there on a die? Front, back, left, right, top, bottom. There are 6. And how many of them have a 1 on them? 1. So I could theoretically roll that die over and over and over and over again, and 1 out of every 6 times on average, now that's going to be a key component, is going to be a 1. This is called theoretical probability. Versus if I actually did the dice roll, just like when I flipped a coin, I can have what's called experimental probability. Right there I got 2 tails in a row. Whoa. All right, 2 tails in a row. I got 3 tails in a row. So, unlike theoretical probability, which makes sense mathematically, which we can do using a math formula, experimental probability means that out of the coins, that's a head, for those of you who can't tell here, there, head. I ended up with 3 tails out of 3 tries, and so I have a 100% chance of getting tails. Now, for some of you, you say, Mr. Moore, that's silly, that's impossible, you cheated. Well, no, I didn't cheat, but I just happened to get 3 in a row. But here's the thing, and this is the one I want to leave you with. What are the chances that if I flip this coin 100 times, that I got 100 tails? What's the chances that if I flip this coin 100 times, I would get 100 tails? I don't think that's going to happen if I keep going. Let's give it 3 more and find out. Tails. Heads. So, in most cases, we would say that me getting 100 tails out of 100 times would literally be not possible. There would be a 0% chance of that happening. But the key to all probability is that it must be random. It must be random. You'll notice I started with a dark container so that I couldn't see. I moved to this so we could use it for the video and we could count them. But really, they all need to be in something I can't see, and they have to be shaken up really good to be random. For the coin, it has to be fair. This I got out of my laundry, so I assume it's as fair as anything else. And I have to flip it good and far. I can't just do the little light flip and get it right. If I'm rolling die, it has to be fair. That's why in Vegas, they make sure it's totally fair. So, all of the probability, whether it's theoretical or whether it's experimental, has to be random, which means without pattern, okay? Or intended pattern, I suppose, because there will be patterns that do come up. So, with that, I know a little bit of a long video, but I know you guys can handle it. We're starting probability.